All right, hello everyone. What we're gonna do is I've decided to just add a couple of new things because you took a test on functions in their graphs, a big one, and you just took it, right? So what I think we're gonna do is I'll just kind of give you a heads up, and we'll talk Monday and see if you guys agree with me. But I really think that it would be better if we learn just a few things that are new going into the final, and then we have like kind of like a quiz. Okay. So we'll have a quiz kind of as the final. It'll be kind of like worth a lot of points, but maybe if you guys did well on your test, we could call, since you just took it, because it was such a large test, we could call that a very large percentage of your final. Anyways, we'll work it out and we'll figure all that out this weekend. I definitely will catch up on the grades because I'm in a state where I'm literally not in pain, like for the first time in months. Okay. So, I'm feeling so much better now. Especially over the last couple days. So I'm actually very excited about getting back, on Monday. So I think you'll find that to your liking, but again, you know what, we will talk about it. Okay. You guys let me know what you think. Okay. So we're going to go ahead and step into trigonometry, and you're going to learn a quick concept because I really want to teach something quick and something that you can kind of absorb, but it's very important. Okay. It's an important thing, but it's a quick thing. All right. So let's go ahead and think about what trigonometry means while I write some stuff down. You guys go ahead and get out your notes and copy this, obviously, right? Okay, trigonometry involves, a lot of people like to think that trigonometry is just about triangles, but what's interesting is that the properties of right triangles tie directly into circles. And that's very counterintuitive, but it's incredible how sine and cosine and tangent and cotangent, cosecant, all of those trig ratios that you learned very briefly in geometry, we're gonna relearn those, and we're gonna kind of extend it so that we can really see the power in not only just like right triangles, which are incredibly important, just in basic construction, right? And all those internet memes are, oh my God, I hear this all the time. I went another day without using the Pythagorean theorem. Yeah, okay. Well, if whatever you're doing, if you're making YouTube videos, or if you are, I don't know, if you work in stuff that doesn't build anything, you are not going to obviously use the Pythagorean theorem. So it depends on where you're going, but it is exceedingly useful in so many fields. Okay. And anyways, even if you don't ever use this stuff, obviously it's excellent for your brain. Okay. It's training your mind to think logically. But enough of the pep talk. What I'm going to say is we're going to focus on a new thing that is going to convert degrees into something a little bit more useful. Okay. Degrees were basically used by the ancient Babylonians, and it was like a base 60. In fact, it was kind of like it's like a base 360, right? A full circle is 360 degrees. Now, why 360? Well, 360 is divisible by many different factors, so it was easily carved up, okay? And that was good for them because they weren't using decimals, okay? They were using fractions. For example, if they wanted to have a fraction like 0.089743, it would look like, one, I don't even remember what I just said, but they would basically just add fractions like this, and that would be their number, right? And that would be kind of how they did decimals, okay? And it just sounds awful to me, but what we're going to do is we're going to break away from that and get to a more engineering-friendly type of measurement that breaks away from degrees, okay? So our goal today is to convert degrees into what are called radians and radians into degrees, okay? So if you have 65 degrees, if you remember how this works, maybe you do, maybe you don't. I'm going to assume that you forgot. What you do is you've got these four quadrants. Obviously, this is the X and the Y axis, but we don't have to, we can kind of ignore that for a second and just kind of imagine this is 0 degrees. And then if we were to have one leg of an angle here, okay? This guy's going to go in this direction, okay? And he's going to go in this direction. And what we want to do is we want to identify where is 65 degrees. And you probably already know, but let's get an idea of where these other angles are, or what they are. This is 90 degrees, so this would be 180 degrees. So if this arrow of the arm of the new angle, okay, if our angle was this, that would be 90 degrees. If our angle was this, it would then be 180. This would be 270. And then coming back around would give us the 360, okay? Now, I know that kind of, I don't want to insult your intelligence. You probably already knew that. But if we are looking to estimate where 65 is, 65 is, you want to think of like, well, if halfway between here, that is 45. So we need, what, 20 more degrees. So if this is 90, our estimate would probably be around there, right? We're just eyeballing these, okay? So 65 degrees would look like that in standard position, okay? This is called standard position. Now, if we wanted to do, let's do, what about 320? We don't need to do a lot of these, but 320 is going to go past 90, okay, past 180, past 270, and 320 is going to be 40 degrees off of this. So using a different color here, okay, 320 would look like maybe around here. Okay, so this guy would look something like this. Okay, and what we do is we draw the arrow to show its direction. Okay, now we are going to go. We are going to go in the counterclockwise direction whenever we're on the coordinate plane. Okay, now that's just now then for our last example, just think of negative, okay? What about negative 15 degrees, okay? We can go in the negative direction. Oh, Laura, I just saw Josh Height messaged me.
Oh, yeah.
Did he message you?
He put a little post on the update that I made.
Oh, he did? Oh, okay. He just messaged me. That's cool.
Is he a doctor now?
Yeah, he's a doctor now. Yeah, you never would have thought it.
The way he talks.
Yeah.
He's like, Achilles ruptures with difficult presentation or really tough recovery. And I'm like, doc.
Oh, okay. All right, okay. So negative 15 degrees. As a former student of mine, I became a doctor. Negative 15 degrees. And negative means that instead of going in the counterclockwise direction, we will go in this direction. Okay? But we're going to change the direction of our arrow. Okay? So negative 15 degrees would look like that. Okay? All right, that's all. I just wanted you to be oriented there. Okay, now what we're going to do, though, is now we're going to shift our imaginations a little bit to think about we're not going to think about 0 to 360 anymore, okay? What we want to do is we're going to convert to what are called radians. Now, if you guys plan on going into any STEM field, radians is it. I mean, everything is in radians, everything. It makes the math so much easier to work with when everything is in radians. So there is this conversion that you will get used to, that you pretty quickly will get used to, actually. 360 no longer equals 360 degrees. What we're going to do is we're going to call it a full circle around the full circumference of a circle with a radius of 1, and that is 2 pi. Okay? So 360, if we're going to say 2 pi, if there's a pi, it's probably radian measure and not degrees. Okay? And then by default, that means that 180 degrees obviously means half of that, right? Just pi. So if I wanted to turn you 180 degrees, I would say to you, turn pi radians, okay? And that is the same as 180 degrees, okay? So it's really just using this guy here will allow you, in a very simple formula, to just take degrees and to convert it, okay? And you've done some conversions, hopefully, in chemistry. I'm sure you've done conversions in chemistry when you talk like grams per mole. You do that linear, what is stoichiometry and linear analysis. Okay, you convert things from one to the other. Okay, so what you got to do here is if you had 60 degrees. Oh, and then we can go back. If we know how to convert degrees to radians, we can go radians to degrees. So here's 60 degrees, okay? What we're going to do is we're going to think of, okay, 60 degrees, okay? Now, if this is pi, okay? And this is 0, and it's also 2 pi, just like this is also 0 and 360, okay? All right, what does this mean here? It's got to be some representation of pi. In fact, 90 degrees is pi over 2 because it's half of 180 or half of pi. So then if this is 1 pi over 2, this is 1 pi. Then going over here is 2 pi. This is going to be half between 1 and 2. So this is 1.5 pi, okay? So half a pi, a full pi, a 1.5 pi's, and then 2 pi. Now how we write 1.5 as a fraction is 3 pi over 2, okay? So 60 degrees is somewhere in here, okay? So what we're going to do is we're going to figure out what pi is not going to be, it's now going to be in our answer, okay? The degrees are going to be gone, okay? So what we do is we multiply by this scale, okay? The scale looks like this, and this is the key to everything, okay? Or it's the first key of 2. We want to put in a pi, and we want to cancel out the degrees, okay? Now what this is like, it's like multiplying by 1, okay? And so the degrees cancel out. And if you notice, well, first of all, there's a 0 and a 0 there. The 10 cancels out, and 6 goes into 18 3 times. So it looks like what's left is pi over 3. Okay, and that makes sense because 360 degrees goes into 180. Okay, so pi over 3 is the answer. Okay, and that is radian measure now. Okay, all right. Let's do a couple more because and then we'll go in the other direction. Okay, let's say that we've got 330 degrees. And we want to convert that to radians. Okay, now we know 330 is over here in this quadrant, right? Just like he was over here. What was it? 320. So 330 is a little bit bigger. Let's convert that to radians by putting in a pi, right? So let's put a degree there. Those degrees will cancel out. Those tens will cancel out. And it looks like 3 will actually go into both of these. In fact, 3 will go in there 11 times, and 3 goes in there 6 times. So this means that you have 11 pi over 6. All right, and that's it. Okay? All right, so really what you're doing is you are reducing a fraction, okay? That's very low-level mathematics. I mean, you're doing this probably in, what, 5th, 6th grade. I guess when you started, okay? All right, well, we might as well do a couple examples of going backwards, okay? So if I have, say, like, if I want to go... Okay, so this is... you know what? Actually, we'll go back to that in a second. Let's go radians to degrees. So if I read that message, is Josh going to give me bad news or something? Is that what he's saying? Laura?
What?
Is Josh going to give me bad news? Is that what he's... Oh, okay. All right. So 5 pi over 18. And obviously, we know that's radians because the pi is there, okay? And so that tells us we're kind of thinking like an engineer, but we want to tell somebody how many degrees it actually is. So they want to step out of their calculations and give somebody's going to put this thing together. They need to give them it in degrees. So what we do is we want to get rid of the pi. So we want the pi to cancel out. So what we do is we put the pi in the denominator and we put the 180 on the top. That's it. This is the second key, is that instead of using pi over 180 to convert the other direction, we go 180 over pi. It's that simple. So now we'll find that these pi's cancel out. In fact, the 18 cancels out. and you're left with a 10 up here and a 5. This is 50 degrees. Okay, 50 degrees is 5 pi over 18. Okay, now you're going to memorize some of the more important angles. Okay, and all in terms of radians. Eventually, you'll get there. It'll come very naturally. But you know, we'll talk about that later. Okay, let's do another example of 11 pi over 9. Okay, so obviously 11 pi over 9. 11 over 9, that's like 1.22, is that right? Yeah, 1.222. So that means what we're talking about, 1.22 pi would be somewhere around here. Okay, so in this third quadrant, but we'll see. Let's go ahead and get rid of the pi and incorporate 180. Okay. All right, so the pi's cancel out every single time. They need to cancel out. 9 goes in there actually 20 times. Okay, and 11 times 20 is actually 220. So I was right. It was somewhere in that third quadrant. Okay, but that's all right. That is not necessary for you to kind of figure out where that is. Just go ahead and do the straight up calculation. And if you do enough of these, you might be able to see that there's a pattern in the fractions in particular. Okay, so with that, the only thing, let me just show you what a negative. Okay, here's our last third example. I didn't label these examples. Sorry about that. Okay, so this last example here, it has a pi, so we know it's a radian. We're going to go ahead, get rid of that pi, and introduce degrees. Okay, so bam, bam. 4 goes in there. Oh, I don't know. Does 4 go in there evenly? No, of course not. 2 does, though. So 2... no, it does. 4 goes in there evenly. 4 goes in there, 180. 4, 3, 4, 5, 4, 16, 2. That is 45. Okay, I should have known that. 45. So it looks like 4 goes in there 45 times. So now we've got -3 times 45. So notice that the negative just stays, okay? So -3 times 45 is -270. And we make sure you put that degrees, and that is it. That is how we convert to. And now, at first, radians are weird, you know, but they eventually become quite second nature. And in fact, once we kind of do a couple more, we will actually stop talking about degrees entirely, and we will just talk in radians. Okay. All right. Looking forward to see you guys on Monday. Have a good weekend.